Okay, so today we are going to talk about compound gear train. Okay, we will take an example on compound gear train. So, first of all, what do you mean by compound gear train? Compound gear train is a train in which you have compound gears. Now, what do you mean by compound gears? So, suppose there is a single shaft and on that shaft more than one gear is mounted. More than one gear is mounted. So this is basically a gear B, or and this is gear C. So you see on a single shaft here more than one gear is mounted. It may be two, it may be three, it may be four, whatever the number is. Okay, but if on a single shaft more than one gear is mounted, that is known as a compound gear. Okay, so if you look at this figure, so this is a shaft on which gear C is there and gear B is there. That means this gear is known as a compound gear BC. So this is compound gear BC. Similarly over here, there is a shaft. On that shaft there is a gear E and gear D. That means we can call it as a compound gear DE. Okay, why? Because on a single shaft more than one gear is mounted. Okay, now we'll get back to the numerical over here. So in this, a compound gear train is shown in figure, consists of compound gears BC and DE, like we have discussed earlier. All gears are mounted on parallel shaft. So these shafts, that is this, and this, all are parallel to each other. Okay. Next, the motor shaft rotating at 800 rpm is connected to the gear A. So basically, motor is connected to gear A. That means gear A is my input. Okay, that means first with the help of motor, I will rotate this gear A, and after that, it will rotate gear B, then C, then D, then F. So this is input, and this will be my output. Okay, then the number of teeth on gears A, B, C, D, E, F are given respectively, and we have to determine the speed of the gear F. So let us write the given data over here first. What is given? The motor shaft rotating at 800 rpm is connected to gear A. That means speed of gear A is given as 800 rpm. Then the teeth on gears A, B, C, D, E and F are 24, 56, 30, 80, 32 and 72. So we'll just note down. So TA will be 24, TB is 56, TC is 30, TD is 80, TE is 32, TF is 72. Now to find what is to be find in this numerical, determine the speed of the gear F. That means NF, we need NF ka value. Okay, now we know the formula for compound gear train, that is the velocity ratio ka formula, that is the speed of driven upon speed of driver is equals to product of teeth on driver divided by product of teeth on driven. Okay, so speed and number of teeth are basically inversely proportional to each other. That's why the formula becomes speed of the driven upon speed of driver is equal to product of teeth on driver and divided by product of teeth on driven. Okay. So let us put the values over here. Speed of driven. So driven means my output. NF, we don't know NF. So I'll just write NF over here. Then speed of the driver. Driver is my input. So that will be NA. Then product of teeth on driver. Now, which is the driver over here? Okay. Which is the driver over here? Let's see. Motor is connected to the gear A. That's why it is the driver. So A is my driver. Now it is in mesh with gear B. Gear A is in mesh with gear B. That's why B will be driven. Now B and C are on the same shaft. So as B is rotated, C will also be rotated. Now let's see here. Gear C is in mesh with gear D. So that's why C is my driver and D is my driven. Okay. Now here E is in mesh with F. So gear E will be my driver and gear F will be my driven. Now just put the values. Product of teeth on driver divided by product of teeth on driven. So driver is A, C and E. So it will be A, C and E divided by product of teeth on driven. It will be B, then D and F. Now we'll just put the values. NF, we don't know. NA is 800. NA is 800. Now what are the values of TA, TC and TE? So TA is 24, TC is 30 and TA is 32. So 24 into 30 into 32 divided by TB, TD and TF. What are the values? Here TB 56, TD 80 and TF 72. So it will be 56 into 80 into 72. Now just calculate the values over here and you will get the answer NF as 57.14 RPM. So it will be nearly equal to the 58 RPM. Okay.